Good evening, all. We have to talk about
Good evening.
yeah,
Good evening.
yeah, I can hear you.
I can barely hear what he's saying.
Can you hear me?
Yes, we can hear you clearly.
Oh,
Okay.
okay, network. It's online class, so barely hearing what anybody's even saying.
So this is about automatic street light system. As you can see, it's
They even
presented
misspelled my
by.
last name as well.
Can you hear me?
Yes, we can hear you.
Yes, we can hear you. Continue.
So presented by I myself, Chinedu Emmanuel and Esther Uchewu. I'm just realizing that I made a mistake in her name. I'll correct that later. Also supervised by Dr. E.S. Mbon. So in this practical, the aim is to design and construct a light-activated automatic switching circuit that turns lamp or LED on when the ambient light level falls below preset threshold using an LDR, that is light-dependent resistor, as the sensing element. If you've watched all these street lights installed by NDDC around the school, maybe if you walked around the hostel, this is part of what makes it function. That is the LDR, the rest. We are about to understand that is the objective or learning outcomes. Understand the photoconductivity principle of the LDR and its characteristics, resistance, illuminance curve. We are also going to design and analyze a voltage divider circuit with an LDR as a variable resistor element. Also understand the operation of an NPN bipolar transistor as a switch. You also use an operational amplifier. The model we use for this particular one is an LM358. As we go on, I'll show you that in the circuit schematics. Also, we are going to calibrate the sensitivity threshold using a potentiometer, or in other words, a variable resistor. The apparatus will be needing, of course, an LDR, the light dependent resistor. Specification is 10 kilo ohms. Purpose to sense light, that is when it's daytime and when it's also getting dark, which will now send information to the microcontroller to know when to turn on or off the street light. Then 20 kilo ohms fixed resistor. Voltage, the purpose is for it to act as a voltage divider partner. Then 10 kilo ohms potentiometer, that is our variable resistor for sensitivity adjustment. Then an NPN transistor, the purpose is for, purpose is for switching transistor. 5 volts relay module for load switching. Then flyback diode, relay core spike protection. Then 20 ohm base resistor, that is 220 ohm for the LED protection and transistor base current limit. An LED plus a 220 ohms resistor as an indicator, the LM358 operational amplifier, for comparator version, 5-volt power supply. You can either use DC adapter or battery as circuit power. Multimeter, voltage measurement. Then lux meter or phone app. We didn't have the lux meter while carrying out this practical, so we downloaded the app on our phone to be. I think the app is Illuminance. You can check that on your Play Store later. It's Illuminance. And then when the practical happens, you see how we used it. Also the AC source to act as a power source for the lamp. So this is the theory now. An LDR, also called the photoresistor or photocell, is a passive semiconductor device whose electrical resistance decreases in response to increasing illuminance. That is to say that once, say for instance, this is night now, and that street light is on. Once as the day comes on, as daylight comes on, the electrical resistance decreases, thereby making this street light to know when to turn off. That is, the resistance decreases. So this behavior is due to the photoconductive effect. Photons with sufficient energy excite electrons from the valence band to the conduction band in the cadmium sulfide semiconductor material, increasing the number of charge carriers, thus reducing resistance. And over here, we have 3 images. The first one, top left of your screen, is an LDR. Top left of your screen is an LDR. Then the top right is an operational amplifier, specifically the LM358. And the one below the two of them is just an NPN transistor. Hope we are following.
No.
Can you hear me? Please, if you can hear me, just respond.
We can
Yes,
hear
Yes,
you.
yes. We can hear you.
Yes, we can hear you.
We can hear you. What is wrong with this stupid phone?
Network.
Kelechi, did you post your screen? Kelechi, can you hear me?
It's like his network is down, sir.
Ah.
Maybe he has a local connection.
Okay, let's wait a few seconds. Kelechi, can you hear me? He's not. Let me even see whether he's still in the meeting. He's no longer in the meeting. He's no longer in the meeting. His network went off, definitely. Okay. Emmanuel, I will make you. Emmanuel, you are there now. Is Emmanuel there?
What is called now?
Emmanuel, are you
Hello?
there?
Yes, sir.
Okay. Let me make you a co-host so that you can share your screen. Pending when he comes back. Or if he comes back, we can use your screen. I hope you can share your screen. Are you using laptop
Oh,
or phone?
no, I'm still using my phone.
Don't worry, let me share. I think, do I have that? Can you share that with your phone now?
I cannot. I think you can share it from your own side. I will just talk from this side, sir.
Don't worry, let me get the slide from the WhatsApp and even though it has been improved on, so I can share my screen, pending when ah, automatic street light. Hmm. Kelechi is not yet back. Okay, he's back. Kelechi, are you there now?
Yes, sir.
Can you hear me? I can't
Yes,
hear
sir.
him. Okay, but someone else can hear me. Is that correct?
I can hear you, sir. I can hear you, sir.
Okay. Uh, Kelechi, we are not hearing you. Can you hear me?
Yes.
Okay, continue.
So I think I stopped at the 220 ohms resistor. So it should come between the LDR and the ground. So connects to the LDR and then goes to the ground for current limiting. Then 10 kilo ohms pot wiper. I think there is a way the LM358 is structured. It has to, should I say, but I think when we come to, I should have put the diagram there also, but then it connects to the LM358 pin 3 that is counting from where the half circle starts on the LM358. Provides an adjustable threshold Then 10 kilo ohms potentiometer goes to the VCC to 5 volt supply, providing power, and also 10 kilo ohms. The same 10 kilo ohms, the other part of it goes to the ground, connecting through a 220 ohms resistor, providing current limiting. And then 220 ohms resistor between potentiometer ground and main ground, providing also a ground. Base resistor 20 kilo ohms between 5 volts and LDR. So it connects to 5 volt supply, providing a signal of current limiting. Then this is for the LM358 operational amplifier. The pin 1 connects to output slash that is output or relay module, providing an output signal. Pin 2 goes to LDR base resistor junction, providing an input signal. The pin 3 potentiometer center, providing a reference input signal. Then pin 4 goes to the ground. Pin 8 goes to 5 volts, providing power supply. 220 ohms resistor between 5 volts and LED, provides current limiting so the LED doesn't get damaged. Green LED anode connects to 220 ohms resistor as indicator. Then green LED cathode, pin 1 of LM358 output, provides also an indicator. Relay common or normally open, connects to bulb slash AC supply for lamp switching. So these are our procedures. First one, before building the switching circuit, measure and record the ROLDR at 5 luminance levels. Use a lux meter or phone that is at 5 illuminance levels. Record 5 values. That is, say, I think while we are doing this, we put one of us had the app on our phone, and we used one of our phone's light to keep on the face of the app. That is, I think your front camera should be detecting the lights coming to the phone. And as it's detecting, your Illuminance app is also reading the different levels. So as you raise it, it decreases, but as you bring the light closer, the luminance level increases. So at 5 different illuminance levels, record the values. 2, calculate the required variable resistor value to achieve a midpoint voltage of VCC/2 at your target switching lux level. I think that one should be on your manual. Assemble the fuse circuit on a breadboard. Have it inspected before applying power. Apply 9, I think that should be 5 volts. Apply a 5 volt supply. Use multimeter to measure V base, V collector, and VCE in both bright light and darkness conditions. Record values. I think that's optional. Rotate potentiometer clockwise while covering the LDR with your hand. Observe the switching action. Identify the threshold position. I think this one is actually saying, as you are rotating, know which point the light should be steady or so. And for 6, Use a lux meter app to measure the luminance at which the relay switches. Record as the calibrated switching point. Repeat the light/dark cycle 10 times and record whether the circuit responds correctly each time. As you can see, this is the circuit diagram. I don't know if I can zoom this up. You see where LDR is positioned. The arrow, the fault resistor, that's a variable resistor connecting to the positive of our operational amplifier. And this is the triangular stuff is our LM358. You can see our bulb that is connected to the normally open. The common is also connected to our AC source. These are relay, the LED, our 220 volts protecting the LED. Also the 220 volts connecting to the ground between the LDR and the LDR and the ground. Row 1 should be our 20k ohms fixed resistor. And I think that should be it. Yeah. So that will be all. Thank you.
Okay, can we let's clap for him now. Let's clap for him. That was a good presentation. Go back to the circuit diagram. So this is the circuit diagram. Just leave the circuit diagram while we take questions. Samuel is raising up his hand. Samuel, you have the floor. Samuel, you have the floor. Unmute yourself and talk.
Sorry, I don't have any questions. It was a mistake.
Okay, so this is circuit diagram you will be implementing when you come to the lab. We have simplified it here. Like he said, you are going to use LM358, LDR, and LED, and the relay module, and then an AC bulb, not 12-volt bulb, an AC source. Emmanuel, later, is it Emmanuel now? Later, you need to ground this op amp.
Okay, sir.
Yeah, pin 4 is not
I think
grounded. It's
at
supposed to be
point 4.
grounded.
Yeah.
Yeah, so you need to ground that. Okay, so having said that, let's go to the cost implication of the remaining 3 projects. You can stop sharing so I can share my screen. Okay, let me share my screen. Just hold on.